Again, what we are doing?
Sir, you said we were doing about that acceleration.
Yeah, after acceleration, we will do the what? Worksheet, right?
Hmm.
Okay, I'm opening the notes first. Here,
Hmm.
you can see the notes, right?
Hmm.
So we did till how much? Here, this point, right? Third point, we are done, right?
Hmm. Yes.
Then continue.
In general, the faster the object travel, the greater the air resistance. When an object falls, it experiences acceleration and an increase in velocity. Uh, this will cause air
Okay, the
resistance.
fourth point. The fourth point, we have some practical experience in our life. Like when you are playing football, right? That
Hmm.
time, if you run faster, then you will feel that the air, air is opposing you to run, right? That means
Yes.
you are feeling more air resistance or greater air resistance. The same thing is happening here in fourth point. In general, the faster the object travel, the greater the air resistance. If you only walk, then you will not understand the air resistance. But if you run, then you'll understand the air resistance. Even if you are running faster, the air resistance will feel more. Clear now?
Yes.
Okay, continue.
This will cause air resistance acting on the object to increase as well. There will be a point where the air resistance is large enough to balance the gravitational force. Uh,
Hmm.
this will cause the resultant force to be zero, and there will be no acceleration. The object will reach constant velocity, which is termed as terminal velocity.
Okay, this
The
part is
magnitude.
clear to you?
Hmm,
This part is totally clear to you?
yes.
Okay, then.
Uh, yes. Hmm. The magnitude of the gravitational acceleration of the Earth is determined by the mass of the Earth and not by the mass of an object. This means that a feather and a bowling ball will fall at the same rate if you neglect air resistance.
Okay, so this point I think you have problem, right, to understand.
Hmm.
In moon, the acceleration due to gravity is 1.6
Hmm.
meter per second square. On Earth it is 10, right?
Hmm.
And the planets which are bigger, they have like Jupiter, Saturn. Uh, they have more
Hmm.
bigger acceleration due to gravity, right? Why
Hmm.
it is? It depends on they mentioned here mass, and mass is related to volume and density, right?
Hmm.
So it depends uh, on density and volume of the planet. or
hmm,
density and volume of the you know any any anything in the space, right? It can be for the star, it can be for the planets, it can be for the satellite, for anything. Clear to you?
hmm,
There is one formula to calculate G. You will get it in
hmm,
A2. There is one topic named gravitational field.
hmm,
Okay, there you will get the idea, detailed idea how to calculate gravitational field strength or acceleration due to gravity. Clear to you?
hmm,
About gravitational acceleration on Earth is determined by the mass of the Earth and not by
hmm,
the mass of the object. The
hmm,
object falling not
hmm.
not depending on this, depending on the size of the system, right? Size of
Okay.
the
Hmm,
thing where it's falling. Now, the second part, they are saying that this means that a feather and the bowling ball, it can be anything, right? Feather or bowling
hmm,
ball or anything you are dropping from any upper place, then they will fall with the same acceleration due to gravity. That is 10 meter
hmm,
per second square.
hmm,
Okay, there is one video you can check in YouTube. If you search with acceleration free fall, Galileo's experiment. Galileo,
Galileo.
yeah,
Hmm,
Galileo's experiment for feather and uh, sphere, that is
hmm,
metal sphere. In vacuum, he did the experiment and he found that in vacuum, both the feather and the steel ball or metal ball is falling uh, and hitting the ground at the same time.
hmm,
Okay, and from that experiment, we understand it easily. Normally, if you are dropping the feather and the ball in the air, then you will see the feather is falling later because air
hmm,
resistance is working more on the feather.
hmm,
So this part is done, right?
hmm,
If it is done, then we are done with this topic notes. We will
hmm.
go to the worksheet, but before going to the worksheet, I will discuss one thing from the test paper.
Oh,
Okay,
okay.
the surprise test paper. Then we will go to the worksheet. Okay, let's go
Hmm,
there. Huh?
hmm.
Hello, Tamjit.
Yes, sir.
So you can see the screen, right? Test paper. You took the test.
Yes.
So please, next time, what you will do, you also add the cover page.
Cover page. Okay.
The cover page I gave you, please add that one. And on cover page, you should write your name, date. It is also a document, right? That which date you did it
Hmm.
and who did it.
Hmm.
Because I'm preserving all this. If I don't see this document, then I cannot recognize it easily. There will be test paper of some more students, right?
Hmm.
Yeah, that's why I need that. Your all the answers are correct.
Oh, all answers are correct.
Yeah,
Yay.
all the answers are correct. Only one thing I have to share with you, that is this one, the fractional one. Can you correct it in your test paper? You correct it with uh, pencil, right? You keep
Hmm.
keep the one you have already. Don't rub it or don't remove it. Just give a circle here. Uh, give a circle here and you write equal. Then you write 5.66. So it's clear too, right?
Hmm.
And you did you print the cover page?
Uh, Cover page said that physics mania, that cover page,
Yeah, yeah.
that
That
one.
cover.
Yes.
Did you print?
No, sir, but I have the link.
Okay. Please print it out in your free time.
Hmm.
Then
Hmm.
write your name over there, and you write the date as well. And above the cover page, there is one place that is obtain marks. In obtain marks place, you write 20. Okay, clear to
Yes,
you?
sir. No, sir, I didn't hear.
Yeah, there is one place in the cover page. It's written
Hmm.
obtain marks.
Hmm.
Okay, that place you
Hmm.
will write 20.
Okay.
Clear?
Yes,
So
yes.
here you will circle, give a circle like this, and you'll write here 5.66. Okay,
Okay. Hmm.
because 2 by 3 means 5.66, right?
Hmm.
Or we can say 5.67, it's better. 5.666, that is 5.67, that is better. 5.67. Am I right?
Yes.
Okay, so this way we write. Because
Hmm.
we uh, normally don't allow these fractional things, right? We want the answer in decimal. Sometimes it happens that they will cut your 1 mark from here for this mistake.
Hmm.
Okay, that's all about the test paper. Do you have any question on test paper or you have any queries?
No, sir, I'm fine. Since I got 20, all of everything is correct.
Yeah, only this
It's
one
good.
you have to make correct. Okay.
Okay.
Now we are going to the worksheet. When?
Hmm.
Hmm.
Sir, I was having some problem in one or two of the MCQs.
Yeah, those we are discussing, no problem. First, we will discuss those. Which one you have confusion? Okay.
Hmm.
Then we will. You send me the solved one,
Hmm.
Amjit.
Yes.
You did not send me the solved one, the worksheet.
Oh, the solved worksheet of uh,
Yeah,
kinematics.
kinematics. Yeah. That
Okay, okay.
one. If you send me, then I can check that your answers are correct or not, right?
Hmm.
Otherwise, it will take time. If you
Hmm.
send me, then I can say yes, this one is wrong. Then I can explain, right?
Hmm.
Otherwise, I have to explain all the questions. So
Yes, yes.
now you tell me which one you have problem. You can see the
Uh,
screen.
no, sir.
Okay, I'm showing the screen. Now,
Now? Yes.
okay.
Okay.
Which one you have problem?
Which one you have problem? Sir, I have problem in sir question number 7.
Question number
Question
7.
number 7.
Okay. So you
So,
couldn't decide, or you have some ideas, but you cannot, conclude that your answer is correct or not. Which one?
yes, I was having a problem with B and D.
Okay, you couldn't take the decision which option will be correct, right?
Yes.
Or you need the whole explanation, right? For the whole question. Can you read the question?
Uh, a skydiver falls from rest through air and reaches terminal velocity. What is the acceleration of the skydiver during his fall?
So here we have some information. When you are
Hello.
yes, there was network problem.
Hmm.
Now,
Okay. No.
when you are reading the question, you should underline this way: rest, right?
Hmm.
Rest means speed zero,
Standing. Hmm.
right?
Hmm.
Rest means what? Stationary or speed is zero, right?
Hmm.
If speed is zero, then acceleration,
Hmm. Acceleration is 0.
yeah, then reaches terminal velocity.
Hmm.
Okay. When it's starting, that time it is zero, but if it starts motion, right? Like
Hmm.
if it is going down and down, then at the beginning we have the acceleration, right?
Hmm.
and this acceleration is acceleration of free fall, and they are saying there is air resistance. If there is no air resistance, then he will fall with the acceleration of free fall constantly,
Hmm.
like the feather one and that ball one, steel ball one, right? Galileo's experiment.
Hmm.
For the entire journey, he started at zero. His speed was zero, but his acceleration, like after 1 second, his speed will be 10 meter per second, right? And
Hmm.
after 2 seconds, it will be 20 meter per second, right? This way, his speed will increase, and this is acceleration due to gravity. Uh, but
Hmm.
there is air is working against the speed, right?
Hmm.
So air resistance is working upwards and his weight is working downwards, right?
Hmm.
His weight is working downwards and air resistance is working upwards.
Hmm.
At one moment, these two forces, you know that his speed is increasing and increasing and increasing. So the way his speed is increasing, the air resistance is also increasing, right?
Hmm.
At one moment, his speed will be constant
Hmm.
uh, as the downward force and upward force are equal.
Hmm.
Okay, they both are equal. That means the upward force is resistance, your resistance, and the downward force is weight becoming equal. So he does not have any resultant force. Does he
Hmm.
have any resultant force?
No, sir.
If he does not have any resultant force, then F equals ma. This formula, Newton's second law, we will apply it next topic. F equals ma. As you were saying, he does not have any resultant force. So
Hmm.
resultant force is zero, right?
Hmm.
If his resultant force is zero, mass can never be zero, right?
No, no, mass is same everywhere.
So 0 by m is giving you zero, right?
Hmm.
Acceleration is zero, right? If acceleration is zero,
Hmm.
uh, that means it is the acceleration when it reaches terminal velocity, constant velocity, right? Constant velocity means what? Speed is not decreasing or increasing, right?
Hmm.
Constant. Constant. I'm writing in short. Huh?
Hmm.
Constant. I'm writing in short. Constant. So constant means no increase or decrease in velocity. If there is
Yes.
no increasing or decreasing velocity, that means acceleration is zero, right?
Hmm.
So theory and numerical both are matching,
Hmm.
and it matches with this, right? Decreasing to zero. starting at the acceleration starting at 10 meter per second square and decreasing to 0 meter per second square.
Hmm.
The answer should be D.
Yes, that's correct.
So you understood it.
Yes, sir. Sir, one more thing.
Yes, please.
Sir, the acceleration of the when the skydiver falls from rest, in how many seconds will he reach 10 meter per second square?
Okay. When he is standing, like, or he is sitting in the aeroplane or any upper place, that time he does not have any acceleration, he does not have any speed, he does not have any distance. Okay.
Hmm.
But when he jumps, falls,
Hmm.
right? When he starts jumping, right?
Hmm.
And he is falling, he starts falling. From that moment, it is 10 meter per second square.
Okay, okay, okay. Got it. Hmm.
Now it's clear?
Yes, yes.
Okay, can we go to next one?
Yes. Next
So
one
which
is
one you have problem? Next.
uh, question number 11.
Question number 11. Okay. Can you read the question and do you think or check? Do you check that you're just now the idea you got, that one is
Yes, yes,
helping you to understand
yes.
it?
It should be a B.
Yeah. So
Okay.
acceleration at T1, it is 10, right?
Hmm.
Can you read the question?
Of 11.
Yes, yes.
At time T1, a stone is dropped from a stationary balloon. The stone reaches terminal velocity at time T2. Which row gives the acceleration of the stone at time T1 and at time T2?
So it is exactly similar idea, right?
Yes.
So the answer should be B.
Yes, B.
So from one explanation, you understood another one.
Hmm.
Then any other problems?
Yes, sir. Of that extended
The
question number
structured
two.
part.
Yeah. Yes. Structured part, question number 2.
Okay, let's go there. Which question? This one?
Yes, 2A.
2A. Okay, 2A. 2A. Yeah. Now I think you can get some idea from my explanation of that
Yes.
one. Can you try
Hmm.
it at home?
Yes, I can try it.
Yeah, you try it and send me. Huh? Send me the worksheet.
Okay,
Okay,
sir.
completely.
Okay, sir.
So that's all, right, for today.
Yes. Hmm.
Thank you.
Okay, thank you, sir, for giving
Allah
your time.
Hafiz.